Welcome to this explainer, where we're going to completely demystify the complex architecture of a Selenium Java automation framework. Today, we're breaking it all down into a 10-layer real-world project structure. If you've ever found yourself wondering how top-tier engineers organize their code to be actually scalable and maintainable, well, you're in exactly the right place. We are going to look at the precise way interviewers and senior developers expect you to know and structure a real project. Because let's be honest, we've all seen them, right? Those messy, super fragile test scripts where absolutely everything is just crammed into one massive file. But today, we're asking a really critical question. What is the actual difference between a brittle, monolithic test that breaks on every minor UI update and a clean, interview-ready automation framework? Well, the answer lies entirely in architecture. It is literally the difference between spending your whole weekend fixing tests or just sitting back and letting the framework do the heavy lifting for you. All right, so here's our roadmap for today. We'll be moving through 6 logical phases. 1, the anatomy of a framework. 2, the core foundation. 3, utilities and data. 4, API and reporting. 5, automation and CI/CD. And finally, number 6, the complete 10-layer blueprint. Let's dive right in with Section 1, the anatomy of a real framework, focusing on project organization. The golden rule here is that clean folders equal a clean framework. Every single concern in a real-world project, from your pages to your listeners and your utilities to your test data, has its own dedicated, specific home in the directory structure. You can easily see how the source test Java directory is neatly divided up. And, this isn't just about making things look pretty. This strict organization is the absolute heartbeat of a senior-level framework. It ensures that when a project scales up to thousands of tests, developers always know exactly where to find and fix the code. Moving right along to Section 2, let's construct our core foundation, which covers the base, pages, and tests. Think of Layer 1, the base layer, as our poured concrete foundation. Here, we have a base test class, where your browser initialization, your driver setup, and your cleanup routines are written exactly once. By using annotations like before method and after method, all this setup logic is automatically reused for every single test. You don't have to copy and paste WebDriver instantiations anymore. It's all centralized. This means if you suddenly need to switch from Chrome to Firefox, you change it right here and your entire framework updates instantly. It's a real game changer. Stepping up from that base, we run into the Page Object Model, or POM. This is an absolutely critical architectural pattern that strictly separates your UI mapping from your test logic. So instead of hard-coding web elements directly into your tests, you create one specific class for each page of your web application. Think about it. If a developer changes the ID of a login button, you don't have to go hunt down and update 50 failing tests. No way. You just update one locator in one page class and boom, everything is fixed. And Layer 2 puts that exact model into practice right inside the Pages folder. A single login page class handles specific locators like username, password, and the login button using by.id. Notice how they're kept private and then smartly exposed through a reusable login method. This means all the really intricate interactions with the web elements are totally encapsulated right here. Your locators aren't scattered to the wind, they're safely quarantined in Layer 2. So, moving to Layer 3, the test layer, we strip out those messy locators entirely. Because this class actually inherits from base test, it doesn't even have to worry about starting the browser. And because it calls the login page object, we are left with nothing but pure business logic and plain English assertions. We simply pass the credentials to the login method and then assert that the URL contains the word dashboard. It is incredibly elegant. When you put them side by side, the contrast is just striking. A messy, old-school test script is usually overflowing with hard-coded driver.findElement calls, which makes it incredibly difficult to read and, frankly, a total nightmare to maintain. Contrast that with our clean Layer 3 approach, where tests focus purely on business logic and assertions. It reads just like plain English, which means even non-technical stakeholders can look at it and understand exactly what the test is validating. Now, let's shift gears to Section 3. Empowering tests using utilities and data to make execution robust. Layer 4 resides securely over in the utils folder. This layer provides all those reusable helpers that keep your tests short, stable, and perfectly dry, meaning don't repeat yourself. This is exactly where you want to store your explicit waits to handle dynamic elements, and finally eliminate those annoying, flaky tests that keep you up at night.
It's also home to screenshot helpers for capturing the state of the UI on demand and random data generators so you can easily spin up unique emails and IDs for every single test run.
Next is Layer 5, which is where we pull our test data completely out of the code. Hard coding data is a major anti-pattern when you're working on a real project. Instead, we store our inputs in external JSON, Excel, or properties files within the Resources Test Data folder. By using features like data providers, you can easily feed multiple different sets of inputs, like valid, invalid, and blank credentials, into the exact same Layer 3 test. You just update a row in your Excel sheet, and you instantly get a brand new test scenario without touching a single line of Java code. On to Section 4, Advanced Integration. This is where we elevate things with API validation and reporting. Layer 6 leverages Rest Assured within the API folder. Now, a truly senior-level UI framework doesn't rely solely on the UI. It uses the API layer for blazing fast end-to-end back-end validation and rapid test data setup. Say you need an existing user to test a checkout flow. Don't automate a sluggish UI signup. Instead, use a quick rest-assured post request to create that user in the backend in literal milliseconds, and then just proceed with the UI test. It saves immense amounts of execution time. And look, when a test inevitably fails at 2 a.m., because they always do, Layer 7 saves the day. This reporting layer automatically generates clean, highly shareable HTML results using tools like Extent or Allure. Combined with our earlier utility layer, it auto-captures screenshots via a TestNG listener at the exact moment a failure occurs. So your team doesn't have to guess what went wrong. The execution logs and visual proof tell them exactly what broke, leading to much faster root cause analysis. Let's move to Section 5, Automation, covering TestNG, CI/CD, and logging to get us production ready. Layer 8 relies on TestNG as the main engine that actually drives our execution. By utilizing the testng.xml file, you can expertly group your suite. For instance, separating a quick smoke test from a massive full regression suite. And even more importantly, TestNG allows you to seamlessly parallelize your runs across multiple threads, which dramatically cuts down the total time it takes for your entire framework to execute. To really wrap our heads around the power of our next layer, let's quickly outline the ideal continuous integration flow. Step 1, code is pushed by a developer, which automatically triggers a Maven build. Step 2, MVN test immediately executes our entire TestNG suite. Step 3, those beautiful HTML reports are published. And Step 4, the QA and dev teams get instantly notified via Slack or email. The best part? Absolutely no human intervention is required. That brings us perfectly to Layer 9, which integrates your framework with powerful tools like Jenkins, GitHub Actions, or Azure DevOps. This is what guarantees your tests run automatically on every single commit. It effectively shifts your testing left, catching bugs the exact minute a developer introduces them, and entirely eliminating the need for manual, local test triggers. Finally, Layer 10 is your ultimate safety net. Using structured log4j2 logs and really strategic try-catch blocks ensures that your exception handling is bulletproof. When something goes sideways in the pipeline, you don't just get some generic, unhelpful failure. You get leveled, structured logs and custom exceptions that actually make runtime failures readable instead of totally mysterious. You'll figure out the why in seconds. With all the microcode layers fully mapped out, let's zoom back out for Section 6, the 10-layer architecture blueprint. So here is the big picture, our consolidated recap. We flow starting from Layer 1's base initialization all the way through the page objects and pure logic tests. These are then empowered by our utilities and external data, scaled up by API integrations and reporting, all the way down to the TestNG engines, CI/CD pipelines, and robust logging. It's so cool to see how all 10 layers elegantly interlock to form one solid, highly maintainable framework that is completely ready for real-world application. Now that you hold this complete blueprint to build a clean, senior-level automation framework, the power is entirely in your hands. So, what's next? How will you apply these 10 meticulously structured layers to elevate your very next real-world project? Dive in, start organizing those folders, and see the difference for yourself. Thank you so much for joining me on this explainer. Have a great one.